chair of the NFL's Musculoskeletal Committee, and we do an ongoing monitoring of all injuries across the board, but particularly the lower extremity and even more so the foot and ankle. And Mike Coffin's going to give you a talk on turf toe next, but these are the injuries that we specifically look at, and you can see them circled there. Our concern with our injuries, particularly lower extremity, is the incident in the NFL remains quite high and consistent. And we're now looking at it in a new way. It's not just the number of injuries that occur or not just the time lost per injury. We look at the entire injury burden, and it's the burden to the players and to the teams. And what it is, it's the frequency of the injury combined with the time lost per injury. And when we look at the charts, we can see that ACL tears are the #1 injury burden in the NFL, followed by hamstring strains. But if you go one more down, you'll see that high ankle sprains are third in place. And again, this is very, very concerning too, as the number of injuries that concern on a consistent basis. And the foot and ankle is not far behind. If you look at the injuries of foot, they're just going up every year in a consistent fashion. And the ankles remain consistently high year after year after year. So again, we're very concerned about lower extremity injuries, but particularly to the foot and ankle, and especially the high ankle sprain. You'll see there that the high ankle sprain, we average about 150 high ankle sprains in the NFL per season. So again, a tremendous concern. Now, high ankle sprains have definitely captured our attention, and most of the high ankle sprains occur by contact. Some direct contact, some indirect contact, but not many occur with non-contact injury. However, the new injury we're looking at is the lateral ankle sprain. You say, well, lateral ankle sprain, that should be a basketball-related injury, inversion injury. But actually, we're finding is that now we're seeing more and more lateral ankle sprains each season in the NFL. Interestingly, these are non-contact injuries. As you see there, that wide receiver in the end zone, nobody's around him, and his cleat gets caught up in the turf, and he gets an inversion ankle injury. This is not new, this whole concept of the shoe-cleat surface interaction. One of our past presidents, Chris Gratton, was on this article looking at torque and injury and asking the shoe manufacturers to display better indications on certain plane surface conditions. So again, trying to decrease torsional resistance in that surface cleat interaction. This is an article I was involved in 2012 showing that lower extremity injuries, particularly ACL sprains and eversion ankle sprains, were higher in incident on field turf than they were on grass surface. And this is the newest article. This is one that came out just recently, where Mike Coffin and I are both involved with. And this, again, looks at artificial turf as a factor. And even more concerning is there's no standardization among the multiple turf types. So it's up to the NFL now to go ahead and understand how each turf behaves with each cleat plate that's allowed to be on that field surface. So again, we're looking at all these various injuries, and particularly now what's captured our attention are the non-contact injuries, because these are the ones that obviously have all to do with the cleat surface interaction. And the injury rate is certainly higher in artificial than natural. So what we're doing now is we test every cleat plate on every synthetic surface that's available to an NFL player to be on. This is what we call the beast testing. And basically it's a traction behavior of cleats on artificial surfaces. So again, we can mimic rotation, traction, torsion, and such on various multiple turf types. And turf types are different from company to company. It's a very, very complicated situation. This is a little bit of a busy slide, but you'll see that what we're trying to do is compare synthetic to grass. If you look at the pictures in the middle, you'll see the divot that's created with a torsional injury on grass. The cleat releases, energy is released. However, on the synthetic surface, you see that doesn't happen. And so again, you get these huge amounts of force that are imparted to the lower extremity. And if that cleat does not release at a certain torque level, you're going to dissipate energy through the lower extremity and create injury. What we've also learned about these surfaces is there's differences in how they're made. You have your seam width, your infill depth. Those together we call the stitch gauge. The wider your stitch gauge, perhaps the safer it is. So it really comes down to the question, slippage. Is slippage good? Is slippage bad? I actually find that slippage can actually be quite good. You release that energy before torque occurs and creates an injury. But it is finding that perfect balance, because the athlete wants a lot of traction. They want a lot of friction, but hopefully we can avoid some of that torque. So if we want to prevent lower extremity injuries, we probably need shorter cleats or wider seams. And our new task force has been initiated. We're excited about this, but we have a task force now underway with multiple industry and corporate people and engineers involved. We're trying to make synthetic surfaces behave more like grass to hopefully reduce injuries. So that's the cleat surface interaction. What about the shoes? The shoes themselves are an issue. We find that things like turf toe, Lisfranc, Jones fractures with increasing incidence may be related somewhat to the shoe and how it's constructed or how it's fitted. Perhaps the shoe's too flexible, then you get your turf toe and Lisfranc injury. Perhaps it's ill-filling, it's too narrow, so the lateral border of the foot hangs off the side of the shoe and imparts more stress to create metatarsal fractures, Jones fractures, and such. So Mike and I initiated an NFL shoe foot sizing initiative a few years ago, where our goal was to measure every player's feet before the season started to get them to the right shoe. We initially did this with a Brannick device, which really didn't do very well. And what we found is we needed something more sophisticated to get the exact right length of shoe to the foot so that your flexion axis lined up with the first metatarsal. You don't want a shoe that flexes outside of the MP axis. And we also wanted to decrease some of the flexion to decrease those turf toe and Lisfranc injuries that are imparted because of excessive hyperdorsiflexion. So again, we went on and we looked at these, we looked at athletic shoes, we wrote a couple of papers on this, and we knew we needed a better system than Brannick. So we worked with HP and came up with what we call the Fit Station. It's a 3D scanner with a pressure mat, and also a volume analysis of all the shoes available to players in the NFL. The whole process takes about a minute. And what you do is you get basically the exact size, you get the exact girth of that person's foot to put it then into the right shoe, not only based on his foot size and shape, but also what's his weight, what's the position he plays. So that's been a fascinating process, and one we're still going through multiple reiterations of too. But again, the whole idea is to get these guys in the right size shoe, particularly the right width shoe. And we've now got the companies to make wider shoes for the power, the bigger guys. Then we also looked at the whole flexion idea. Again, we're trying to decrease hyperextension, but still allow the guy to perform. So we've done all kinds of computer analysis. We do these flex testing of the shoe itself. We've got cadaver modeling, we've got computer modeling. And what we're doing is we're trying to do injury modeling of not only the turf toe, but Lisfranc and now high ankle sprains with all of this excellent biomechanical engineering technology. But again, our biggest concern was, okay, how do we protect these guys but still give them the performance they need? What we did is we brought a bunch of elite athletes into the lab, and we found exactly what do they need as far as forefoot flexion or hyperextension, ankle motion, all the various vectors you can see there. What do they need? What are the trade-offs if we make the shoe stiffer? And what we found is that, particularly with the turf toe and Lisfranc injury, there's this performance regime and there's an injury regime. And basically, there's we know this is the amount of flexion they need to perform and be an elite athlete. But at this level, this threshold, you get injuries. And so we have this basically this gray zone between that we can work with the companies and decrease flexion at that level to hopefully decrease some of the injuries we're seeing. So this is the fast testing. This is the apparatus we use to assess how much flexion there is in a shoe. And then what we do is we put out this chart, and this chart ranks the cleats. This is the 2019 cleat chart, looking not only at how they did on the Beast turf testing, but also their flexion characteristics of the shoe they like to wear. And again, we then provide them that with the support of the NFLPA to try to get them into the most safe shoe possible. One of the newest things we're doing now is we're actually putting barcodes in the shoes. This is the RFID tag in the shoes. Basically, we need the denominator. We need to know how many shoes of what type are on the field at any given time to determine which are those at risk. We started with a pilot study, but this past year, all the teams were involved, and we recorded all shoes that were worn on game day in the NFL. So this will now be basically a scannable thing where they'll just walk through a platform and we'll automatically know what kind of shoe is being worn on the field, as well as what helmet and shoulder pads and everything else. And then we're really excited because the newest task force has been initiated. Again, one that Mike and I are intimately involved in is the high ankle sprain syndesmotic injury task force. We really don't know how a high ankle sprain occurs. And so what we're doing is we're trying to work backwards. We're looking at the guys from a demographic process and epidemiologic process. We're finding out, okay, who had the injury? And then what we do is we go back and look at the video. And then Mike and I have gone and we've reviewed literally hundreds of MRIs, CT scans, and x-rays of those individuals that had a high ankle sprain and try to put it all together. What characteristics match what video analysis, and then exactly what position they played. And then from there, we'll go to the outcome and our ultimate goal of decreasing the incidence and severity of these high ankle sprains. So this has been a very exciting time in the NFL. Again, it's not so much about treating the injury. Again, Mike's going to talk to you about the turf toe, but we're not changing much as far as how we treat the injuries in the NFL. It's more about how do we prevent some of these injuries from occurring. And we're getting there. We've got a better understanding of the injury patterns of late. We're trying to influence and enable industry to do a better job, not only with the building of their shoes, but manufacturing of synthetic surfaces. Again, we've worked hard to try to get wider shoe options, stiffer shoes to reduce turf toe and Lisfranc, which looks, at least anecdotally, like there's a trend towards decreasing those injuries with stiffer shoes. And again, we're trying to make turf mimic grass. We continue to monitor this. We provide tools and expertise. And a big role too that we have is to educate the players and other stakeholders of safety and how it's not all just about appearance, that there's prevention things that need to be considered as well. So again, we're still fighting this thing that the shoe is an apparel and not part of the protection and equipment that these guys wear. It's medicine, not just marketing. We got a long way to go, but it's been an exciting year, and I'll be able to hopefully tell you more about it next year. Thank you very much.